Now, as said before, you are going to finish class practice 37.1. While we are waiting, please take a look on that again. We will have a discussion on that shortly. Okay, you may turn on the camera, and I would like to check your attendance now. E3. Clement Chan, are you here?梁君如, are you here? Sầm Zihian, are you here? All right, so please turn on the camera, and we'll like to start off the lesson now. Okay, on chapter exercise, class practice 37.1. Okay, so 37.1, the questions on comparing the different rates data. So do you see that? Okay. So this is the questions about studying the rate of reaction between X and Y. So with a mark cross below the conical flask. So the student has attempted 3 trials, but you may see that it gives a different combination of a volume of X, water, and Y. And the time, it is defined as what? The time taken for the cross to become invisible when viewed from above. Okay, so this is the definition of the time. What is the effect if any, of increasing the concentration of X on the rate of reaction, increase the concentration of Y on the rate of reaction, just like yesterday, right? So we have got 3 sets of data. Which data should be chosen for you to answer A? Okay, for Y, for B part Y, you need to choose another set of data. Okay, you know what to do. So A part. Anyone who can help? A part. What data we should be compared for A part? X, increasing concentration of X. Now, in this case, which means that the independent variable, right, for A should be what? Concentration of X, while the independent variable for that should be concentration of Y, respectively, right, for these 2 cases. Remember. So the rate of the reaction is the dependent variable. Okay, while the measurement method is the time taken for the macros to be invisible when viewed from the above. Right? Just recall your memory. So there is one variable missing, isn't it? What is that? One variable is not mentioned. Independent variable mentioned, dependent variable mentioned, one more variable. What is that?
Control variable.
Yep, control variable. So in order to choose the 2 trials correctly, you should have a sense in control variable as well. Okay, so what is meant by that? So for control variable, for that, it should be concentration of what? For A part, this is concentration of Y. While for if you take a look on B, in the control variable is concentration of X instead. Do you understand? Do you know why? You cannot have the comparison of 2 data with 2 factors changing. Okay, otherwise it's not a fair test. You understand? So can I have A part? Chen Yunzhong, A part. Which 2 trials will be chosen?
One and two.
1 and 2. 1 and 2. Take a look on 1 and 2 first of all. Okay, is it in line with our understanding that independent variable is concentration of X, control variable is concentration of Y? If you say that independent variable is concentration of X, which means that the concentration of X are increasing, right? So which means that concentration of X should be changed. Okay, should be different in 2 cases. While for control variable, you should be keep this one the same, keep constant. Yes, 1 and 3 instead. Yep, 1 and 3. Take a look. 1 and 3. For A part, there should be 1 and 3 instead. Take a look. 1 and 3. The concentration volume of X has been changed, which means that the concentration has been changed. Okay, while Y, they are of the same volume. Now you take a look on the 3rd item, X, the volume of X and water. So you are going to add them together to form the total volume of a solution being what? You add it total, first of all. Add 3 as a total, which means we are having 30 cm cube of the solution. Okay, so which means that in that solution volume, concentration of Y is the same, while concentration of X is different. Can you get my point? But we focus on these 2 only. So the role of water, the volume of water, is to add it until the volume of the total solution mixture constant, so as to maintain a fair test. Okay, so as to make Y, for example, a constant the concentration of it should be the same throughout experiments. Okay, in these two experiments at the start, what I mean is, okay, so 30 cm curve, 30 cm curve all together added together. So water here plays a role. Do you understand? Comparing trial 1 and 3, can you tell quantitatively what happens between the two? When the concentration of X, which one is a higher concentration? This one, right? Higher, lower. So what happens to the time? What happens to the time? What happens to the time? Now, can you tell me the change in concentration of X? How does it affect the rate?
When the X is added by 2 times of the trial one volume of X used in trial 1, the time change
Yeah, so conclusion, the question comes from a concentration and rate of reaction. Now, what you just mentioned is volume. How would you relate volume to concentration, first of all? Now, you just say that volume. Now, I can follow your logic here. Volume of X is double, right? From 5 to 10 is doubled,
yeah.
Which means that the concentration of X is what?
Double.
Also double. Also double. So the time taken for the macros to become invisible when wheel from above. So what happened to the time is halved, right? So
yes.
How does it relate to the rate? How does it relate to rate?
They 快咗倍咯個 rate.
Why?
Because the time is halved.
Time is halved.
If you use half of the time to complete all the reaction.
Yes. So what is the mathematical relationship between rate and time?
Rate 越多 time 就會越少。
Mathematical relationship.
Yeah.
Yes, mathematical relationship. You just tell me something like a qualitative relationship. How about quantitative relationship? Rate and time. What is the mathematical relationship between the two? As rate is
rate 等於1 over time.
Yes. So what is that in English? We call it, they are in what relationship?
I don't know.
Negative relation. Inverse relation. Oh, forgotten. It seems many of you have forgotten that sentence. So what is that? We would call that as an inverse proportion. 反比. Okay, you got it in mathematics, right? So inverse proportion. So you will say that the rate is inversely proportional to the time taken. So which means that the rate is doubled because the time taken is half, right? So you have got the relationship. Can you get my point? So in other words, if you go back to the questions, can you answer them now? So take a look on this one again. Increasing concentration of X on the rate. So you must underline concentration of X here and also rate in order to tell the answer, right? At least you need to have that too. Now concentration of X is doubled which means that the rate is doubled. Okay, which results that rate is doubled. Rate of reaction is doubled. Do you understand? So, if you want to have a further look, on that, how can we know the concentration of X is being doubled? So it is adjusted by adding the volume of X. Okay, one should be 2 times over the other. So while keeping the total volume of the solution same, you can have such relationship. Do you understand? So from the preliminary data, they just tell you this, okay? Or what you had just got is volume. But how can you make a bridge between volume and concentration is the effort of you. You have to tell. Do you understand? So similarly, now time is also something very strange. You begin the time, but you are going to relate to the rate. Can you get my point? So how would you relate time and rate is also your effort. You have to tell. Now, for the second case, you know that we have got that mathematical relationship. How about the first one? It's better to make it as a first one as a mathematical relationship as well. How do you relate the volume of X and concentration of X? How you get the concentration actually? Concentration of X is equal to number of moles of what? X over total volume of solution. Do you understand? So how you make the concentration of X relate to volume of X? Number of X is calculated as what? This part, constant volume of X, it is calculated as molarity of X times what? Volume of X. Do you understand? So that's why if you found this one, the concentration of X and volume of X, what is the relationship in mathematics? What is that relationship in mathematics? Concentration of X, it is, how will you say it? In mathematics, how will you say it? First of all, molarity of X, is it the same for these two cases? How about total volume of solution? Is it the same for these two cases? Now, if so, how would you relate them to concentration of X and volume of X?
Equals. Equals.
What? Equal. I can see Lưu永saying is equal. How about you,
The total volume is equal.
Yes, I know. Total volume is equal. How about molarity of X? It's also equal. So that remember, molarity of X means before adding. The original molarity. Now, I don't want to get confused with all of you. That because they are before mixing, they are in separate bottles. Okay, upon mixing, the concentration of X is it means after mixing. Do you understand? So what is the relationship between the two? Yes, somebody write in Chinese to me. Yes, that is correct answer. Could you please tell it in English for Zihao? What is that in English? For Zihao, what is that in English? Now you know that this is 反比. This is inverse proportion. How about this?
Proportional to.
Yes, we call it direct proportional. Directly proportional to. So in make a relationship, we call that direct proportion. 正比. Do you still remember that? Now remember, these two hasn't been changed, which means that these two, you make a constant number throughout the whole experiment. So which means that these, if you want to make an expression between the two, it is just a constant times this. Okay, so in order to give such mathematical relationship, we call that direct proportion, while K here is a constant. Okay, I know it's constant because the original molecular X is still in the same bottle, right? The X is still in the same bottle. I did not change its concentration. And later on, the total volume solution, I keep it the same. So altogether, that data should be the same, irrespective of trial 1, 2, and 3, right? Do you understand? So we call it direct proportion. So in order to do so, you may see that where volume of X is double, concentration X is double. So this is direct proportion. You understand? Which means that volume of X is 3 times larger. Concentration of X should be 3 times larger. Can you get my point? Volume of X is 10 times larger. Concentration of X should be 10 times more concentration. Do you understand? We will call that direct proportion. How about inverse proportion? Now, inverse proportion, which means that rate and the times together to make a constant. So, which means that you are going to multiply that two data to form a fixed number, which means that when one increases, the other must decrease. Mathematically, can you get my point? So, mathematically, if you say that time is halved, the rate is double, or vice versa. Time is double, which means rate is halved. Do you understand? So it is somewhat that you should know about mathematics. A deeper understanding of the term direct proportion and inverse proportion in other subjects, especially in science. Okay, you should get looked to this. Any questions so far? Anyone who understand or don't understand, let me know now. Okay, understand, take, not understand across in mathematics. Tell me. You understand now? I just want to double check if I need to have a further elaboration on direct proportion and inverse proportion. That two concept is different. How about the others? Not really get. I see. When you have some questions in mind?
Yes.
Just ask. Tell me. Just ask which part. Sorry, can you speak louder?
I want to know further about the mathematical part. I don't really understand by this part.
The concept of direct proportion and inverse proportion, you have some basic understanding of it, right?
Yes.
Now the question is, if you apply it to chemistry, what would it be like? Now take a look on this question. It's very, very strange. It's because the data given is just indirect data. Okay, they do not give you the exact data. How do I say so? Now you take a look on X. They just give you volume of X, but not telling you the concentration of X just after mixing. You have to calculate it by yourself. How would you relate the volume of X, change in volume of X to the molarity of X after mixing? Do you understand? So you may see that that two items, volume of X is double, concentration of X is double. You should tell it by you yourself, but not the question. Okay, so that's why we call this data a very indirect data. Do you understand? So
okay.
You have to show it vividly. You have to show it clearly that there is a relationship. Okay, so that's why the blue one is an indirect data. You come to your own data for your own use, which matches with the question. Can you see that the question asks for concentration of X, but based on the data above, you do not have any direct data to tell you concentration of X. You have to calculate by yourself. So that is the mathematical way to express. Okay, but what is so strange is that you are going to tell to compare two cases in which there is a change in concentration of X only. Concentration of X must be changed only, but not other. So please choose 1 and 3. Can you get my point? Because only 1 and 3 with that comparison would have a change in concentration of X only, but keeping concentration of Y the same. Can you get my point? Because it does make sense. Because for that questions, if I want to make a case simpler, the case is just involving the two chemicals. It is X and Y. Okay, X and Y. You are going to test how does the concentration of X affect the rate of reaction, and then how does the concentration of Y affect the reaction. So in order to make a fair test, which means that you are going to change the concentration of X only, okay, and then try to see what is the behavior of the timing while keeping other constant. Do you understand? You understand that part?
Okay.
Yep. And then what's next? What's next is another the same trick. It is the what I just got the result is just time but not rate, right? So my question is, you have to tell the reader, the marker, the examiner, you let us know that you know. Let us know that you understand the concept. Rate and time should be in direct. They should be in inverse proportion. Okay, so you have to state that clearly. Rate is inversely proportional to time. So when the time is half, the rate is double. Can you see that? The blue one is indirect data. It's indirect data, but the red one is what the question asks you to give it as an answer. Can you get the point? So you are going to bridge the blue one to red one, blue one to red one. And reading the whole flow from these to this, you may have the logical sequence like this. Do you understand?
Okay.
Do you understand? Do you understand the whole logical flow now? Now,
Okay.
Let's try it again on B. Now, have a testing on B. And if you can successfully write something like this, okay, I would know that you understand for B part. How about B? And when you first of all, please choose the two trials for you to compare the concentration of how does the concentration of Y changes will affect the rate of reaction.
I will choose 1 and 2.
1 and 2. 1 and 2. Take a look, right? 1 and 2. Now the concentration of X, now this is indirect data. This is the volume, right? But I know again the total volume of a solution is the same. So which means the concentration of X is the same. So it is a concentration of X being a control variable. Do you understand? How about Y? Y 10 to 20. So the concentration of X, it is changed, right? What is the changed? What is the change? 1 and 2, yes, that's correct. So you are going to write down B part here. All of you, please mark it down for B. And for B part, what is the changed? One and 2. Yes, you are going to compare 1 and 2. Okay. So who can continue? What is the mathematical relationship? It's good to compare 1 and 2. Yeah. Now please continue. So what is the change in concentration between 1 and 2? Yeah.
When concentration of Y is doubled. 係嘛？好似係double.
Yes, it is double. Is it? Is it double? 10 to 20.
Volume of Y is double.
Or volume of Y is double. What is the constant? What's the change in concentration of Y?
It's also double. Yeah.
Yes, it's also double because the base is a 30 cm cube of solution. Okay, 10 over 30, you change to 20 over 30, it's still double. Okay, and then so how about the time taken?
The time taken for make cross to be invisible.
To become invisible.
Invisible.
Invisible. Okay.
Invisible when
when view from the above is
is not changed.
Yes, is unchanged.
It's unchanged.
Is unchanged. Is unchanged. So what is the relationship? So how does it affect the rate? As you know that rate, it is inversely proportional to the time taken, right? So what is the conclusion? The rate of reaction
The rate of reaction.
Yeah. How does it affect the rate of reaction? Is the time the same?
Direct proportion.
Direct proportion.
Okay.
Unchanged, which means that 112 second, right? So changing, would the changing of concentration of Y affects the time?
No.
No, which means that the rate of reaction is it doubled?
No.
So how would you say it?
It's not double, so it is in inverse proportion.
Inverse proportion.
Yes.
Now,
Remains unchanged.
Yes, it's also the same. Okay, remains unchanged. So, so what is the mathematical relationship between the two? Concentration of Y and rate. Now you hasn't told anything, right? Concentration of Y changes. How about the rate of reaction? Would it tells you no change. So what is the relationship between the two? What is the mathematical relationship between the two?
Equal.
Equal. So what does it mean by equal? You mean the concentration of
Y
is equal to the rate?
The weight of the reaction.
Say that again. Yeah.
The concentration of Y won't affect the rate of reaction.
Good. That's correct. The concentration. You just say. Who just said so? I cannot recognize you. Sorry. 你邊個聽唔到？我啱啱聽到。
譚志仁。
譚志仁啊 ，good. Oh, good. Okay. Who taught you Form 1 IS, right? He was a very good teacher, right? Teaching you. Fantastic. Now, so it is what you know it in this one. There is no relationship between concentration of Y and rate of reaction. Okay, just like what Tam Jian has been said, concentration of Y does not affect the rate of reaction. You can have such conclusion. Okay, so it is quite common to see in scientific research. The scientists would try their very best to understand the phenomenon, right? By thinking, by hypothesizing, which affects which and how does it have an effect. But of course, during the whole progress, you just make a guess. You think that this may affect or that may affect, but I don't know how what effect would it bring. Can you get my point? So that's why they would use fair test, the concept, to rule out and come up with the conclusion whether or not there is an effect. If there is an effect, how is the effect be like? Can you get my point? So there are two concepts. One is you are going to test whether or not there is an effect. There can be no effect, right? It's just based on a guess. And after doing this experimental findings, from the experimental findings, it will tell there is an effect or there is no effect. Do you understand? That point number one. Point two, if you know there is an effect, by merely inform one, you just tell me that increase and the other one will increase. You are going to tell mathematically what is the extent of increase. Okay, can you get my point? So in case, just like this case, when the concentration of X is double, the rate is double, which means that it is in direct proportion. We will have a case that, for example, concentration is double, but for rate it is times 4. Do they have such a chance? The answer is yes. You can have such a chance. If that is the case, concentration and rate, they are not in direct proportion. You have such a chance. Can you make a guess? So what can it be? If that is the case. Now I'll give you one more hint for the same case. Concentration it is triple. The rate will be times 9. Mathematically, what is the relationship between the two? Do you know? You don't understand. Could you understand what is that? Now there is such a chance. If that's the case, what is the relationship? I will not tell you it's direct proportion. It doesn't make sense, right? So how will you relate them? Now, if it is direct proportion, which means that concentration times 2, rate times 2, concentration times 3, rate times 3, but not like this. Anyone who can tell, anyone who can tell it in mathematics, what is the relationship between that? No.
知道佢係 square 咗咯，即係
Yes, that's right. Rate it is directly proportional to the concentration square. Do you understand? So the mathematical relationship will be this. Rate is directly proportional to the concentration of the chemical square. Do you understand? You understand? Your facial expression, it seems strange. You understand? Liu Yinzhong, do you understand that in mathematics? Rate is directly proportional to concentration square, which means that concentration double. It is 4 times. So which means that the concentration 2 times, okay, and then square. So of course it's 4 times. So once I put it 3 times here, right? You make it square, it is now 9 times faster. Do you understand? So that is also happening in your exam. Okay, that is also happening. So that's why I just say to you, merely by telling me that concentration increase, rate increase, it doesn't tell clearly the mathematical relationship. There are so many relationships, they can tell you positive relationship. Now, what do I mean by that? In mathematics, you will say that this is also a positive relationship, right? you can also tell this is a positive relationship, okay, with a curve upward. Can you get my point? But are you talking about the same thing? No, the answer, they are not the same. Even though you talk about these two, they are positive relationship. That mathematical relationship, they are not the same. Do you understand? For this one, they for x value increase, the y will increase to the same extent. But for this part, increase in x a little bit, the increase in y will become larger, much greater than the before. The larger the value of x, the larger will be the increase in y. Do you understand? So the increase is not gradual, while this one is the gradual increase. Okay, for the gradual increase, it is direct proportion. I teach you something about mathematics today. Do you understand? Zakaim, could you please say it once again what I've just told about this? What I just said about this?
What do you mean?
可唔可以重複一次我頭先講咩？
咪兩邊一齊升，咁咪 direct proportion 咯，唔係嘅。
兩邊一齊升就 direct proportion. How about the one on the right hand side? Right hand side is it direct proportion?
等我縮細啲。唔係啊。
呢個唔係嘛？咁 but it also tells you your sentence, your statement. You just say that when x increase, y increase. Can you get my point? So once you say that when x increase, y increase, that sentence is not accurate enough to tell the mathematical relationship. Can you get what I mean? 唔明。Because your sentence is too general. 喂，做咩啞晒喎？你班友？
我明。
你明我講咩啊？你講一次啊！你講一次俾全世界聽啦。用你 whatever language。
即係話呢個即係就咁講，佢increase 就唔點講，唔係一個 accurate 嘅説法咯。即係如果要講係同時一齊 increase 嘅話，就要用 direct proportion 咯。
同時一齊 increase，
即係
咩個一齊 increase？ 兩個 case 都係㗎，而家你呢兩幅圖，兩個都係同時 increase 㗎。
同一個 rate 地 increase 係咪可以咁講？
唔緊要啊，你哋成班 Chem 都講得明就得㗎啦。
唔識解釋添。總之同一條直線上啦，一條直線咁上，一齊上咁咪唔識啊！我都唔識點解。
係都 good try 㗎啦，你起碼知道認個圖畫嘅形狀，你知佢係咪 direct proportion 啊？好，仲有冇其他人可以講得到頭先阿 Sir 想講乜嘢？
佢應該係講話係兩邊升嘅幅度都係一樣咯，左邊個圖，咁所以就係 direct proportion。咁右邊個幅圖就係佢一開始係個 x 嗰邊升得多啲，唔係係 x 嗰邊個數字升得多啲，然之後個 y 個數字先升翻多啲，所以佢呢個就唔可以話係 direct proportion。
x 嘅數升得多啲，就 y 再升得多啲。
即係一開始嘅時候，x 同 y 個升幅個比例唔係一樣。
係。仲冇第三個講法？頭先我講緊咩啊？我呢度即係我呢個 example 想話俾你聽咩啊？知唔知？有冇人答到？冇啊，冇反應啊！揾多個人講啊！揾多人講唔緊要，我起碼聽你哋係咪真係明定唔明啊，大佬？ 揾多個鄭希哲。我呢度講咁耐，即係想講咩？
即係解釋個 rate 同埋個 concentration 嘅關係咯。
係咯。咁有乜可能性啊？你講關係啊嘛。咁第一個可能性係咩啊？有乜可能性啊？講你聽。即係有咩結論可以出到啊？有機會係。
即係 concentration 升嘅話，咁個 rate 就會升咯。
好，升啊？點升法啊？
即係會
好 ，Chem 2 students, do you understand why I keep on saying such? It's because of that of these answer. I just show you 3 cases. Do you understand? For the first case, if you want to relate concentration of one chemical to the rate of reaction, you can have a conclusion that there is no relationship. 你一就有關係，一冇關係。你可以話佢冇關係噶嘛？咩叫冇關係啊？冇關係就係話no matter how large or how small the volume, the low the volume of the concentration of chemical added, the rate of a reaction is still the same, is still unchanged. 嗰隻 chemical 嘅濃度點改都好，個 rate 都係不變。咁呢個就叫冇關係啦，明唔明？冇關係即係話佢點樣喐都好咧，都唔影響緊我嘅。跟唔跟到先呢個？明唔明？喂，你話俾我聽先，一個明一個唔明啦嘛？明啊嘛？係咪明啊？呢個明啦咪？好啦，第二個就係有關係。有關係係點樣有關係啊？咁有好多種叫做有關係嘅嘢㗎。咁不外乎咧就會係如果講濃度啊，濃度升嘅話咧，不外乎有兩種關係。第一種關係咧就係左手邊嗰個，佢個升幅係均等嘅，即係話咧，譬如 X 個單 X 個濃 X 個 axis 咧，佢係升一格嘅話咧 ，Y 隔離都會升翻同等個格數㗎，未必係升一格嘅。例如係話呢度你係1、2、3、4，呢度你係1、2、3、4都得㗎嘛，係嘛？不過你亦都可以係當你1、1嗰時，我可以係1、2、2、4咁上都得㗎，咁都係叫做正比例嘅，你明唔明啊？咁我就係講緊呢度每升高一格嘅每一個間隔係一樣嗰陣時，呢邊嘅升嘅間隔咧，佢哋係相互之間係一樣嘅，即係佢 x 幾升幾多嗰個幅度係一樣嘅，所以我就叫 gradual increase 啦，明唔明？咁但係咧 x 同埋 y 咧有機會咁樣曲線上啊嘛，曲線上嘅意思係咩啊 ？x 升得升 x 係上升嗰時咧 ，y 咧係會上升，不過佢個升幅係越嚟越高，跟唔跟到？即係話 x 嘅數值越大咧 ，y 嘅數值咧，佢大起上嚟，再比之前個細嘅數倍大得更大，就叫升幅高啲啦。所以咪曲線咁向上咯，跟唔跟到？咁如果呢個 case 嘅話咧，呢個唔係叫正比嚟嘅啦，呢個係正比，呢個唔係正比啦。咁有陣時個 mathematical relationship 係話俾你係 square 嘅喎，咁 square 嗰啲咪 up 翻 square 咯。個 square 嘅睇法咩啊？當佢 concentration double rate 就係4倍 ，concentration 係3乘3時，佢就會9倍增幅。咁呢種咧就係 square 啦，個關係就係 square 啦，就 rate 同埋 concentration 嘅 square 係成正比例啦。呢條式你咪喺即係你學數學嗰陣時，你咪學過咯，就 y 等於 x square 啊嘛，係咪啊？係 parabola 啊嘛，記唔記得佢啊？ 咁你嗰個 x 可以前面係一個數值 k 都得㗎，1x、2x、3x 都係咁樣㗎，3x square 都係咁樣㗎，個 curve 個形狀都係咁㗎，明唔明啊？咁當然我哋喺 science 喺 maths 嚟講唔會講呢邊啦，因為唔會有負數啊嘛 ，concentration 唔會有負數㗎嘛，跟唔跟到？所以我哋咪淨係望呢一忽咯 ，get 唔 get？咁所以咧，究竟佢個關係係乜咧？你就由個數值上面講啦。而頭先咧，我哋頭先梁君宇講個問題就係話，藍色我哋啲 data 咧就唔實在嘅，因為佢唔係直接話俾你聽 concentration 啊嘛，所以你未個藍色 volume 嗰個數，你要去俾個關係佢話翻俾我聽，佢同個 concentration of x 嘅關係咯。咁 time 亦都要諗翻上 rate of reaction 嘅關係咯。你先可以將 concentration of x 同埋 rate 扯上關係咯，因為你上面嘅素材淨係得 volume 同 time 咋，但係我就想問你 concentration 同 rate 啊嘛，所以你咪諗翻 volume 係同 concentration 有關係 ，time 同 rate 有關係咯，所以你先可以 up 到 concentration 同 rate 嘅關係咯 ，get 唔 get？ 喂，聽得明嘅答我啦，明唔明就唔明啊嘛，一句冇反應啊 ，hello， 明定唔明？
明嘅。
明係嘛 ？OK 啊，有問唔明啊？而家唔明啊，舉手，快啲，我哋講，唔知我乜？嗱，你 maps， 因為呢個係 maps concept 嚟㗎，同學 ，maps concept 嚟㗎。
阿 Sir，
係
係好似嗰個咩 Parmesan 嗰個東東
Parmesan 嘅東東，你咪 form 4 maps 講嘅嘢咯。佢有機會佢有個數值係，譬如呢啲數值個 time 搞完一大餐，你轉翻做 race 嗰陣時，發覺原來係咁嘅關係嘅。即係當佢 concentration double，race 就係乘4 ，concentration 乘3個 rate 就成9，或者係你想 concentration 乘4咧個 rate 就成16嘅。咁咩意思啊？就係當個 concentration 升得越多嗰陣時，佢個 rate 咧佢有升幅嘅，不過升幅越嚟越急。咁呢個咪越嚟越急嘅畫面咯。呢個咪就係個 hyperbole 咯。咪拋物線咯，拋物線嗰條式嘅 equation 咪想過話俾你聽呢樣嘢咯。
OK。
當 x 係1，y 等係1啊嘛。當 x 係2，y 就係4啊嘛。當 x 係3，y 就係9啊嘛。當 x 係4嗰陣時 ，y 咪16咯。話俾你聽咩啊？咪就係大家都係升噶，係嘛？但係升得嚟越升越急啊嘛。咁呢個咪？而個關係係 square 嘅話，呢個咪個拋物線嗰個 formula 咯，話俾你聽嘅嘢咯。Hello，OK， 明係嘛？咁我就有啲唔明啦。咁係咪你哋上咩試堂時其實唔係好明咧？係咪上咩試嗰時唔明㗎呢啲嘢？
咩事而家教緊cycle side tangent？
唔係我咁呢啲樣嘢你學過㗎嘛？學咗啲語句上學咗㗎啦。
有好似有，
好似有，咁有定係有定冇啊，大佬？
有
嘅。
有啊嘛，係咪啊？唔好嚇我喎，即係要我問翻咩事老師啊，真係，唉，大件事啊，真係。好，要 try to take a look on question two。咁你要搞清楚啦，究竟個關係咩？即係我哋咧呢度咧係呢種嘅關係咧，我哋叫 deduction 啊，即係隱含咗一啲嘅數據，要你望住啲數據話翻俾我聽個關係，就唔係咩事，咩事就係 inductive 噶嘛。我哋 inductive 佢係 deductive 噶嘛，即係話佢俾咗條式你，跟住條式咧就話翻俾你聽佢嘅關係啊嘛。我哋就唔係啦，我哋而家就俾緊啲數據你咪睇翻呢個數據嘅改變，可以估翻出佢哋嘅數學上面嘅關係，明唔明？調翻轉諗嘅，所以有同學會覺得難嘅呢個位。咁你點樣可以答得我呢部個層次係高啲嘅？因為你首先你係要明白個數學嘅關係有啲咩個可能性啊嘛，跟住你就腦入邊你見到啲 pattern 諗翻轉頭，原來呢樣嘢我學過嗰個 concept 啊嘛。係嘛？你明唔明我講咩喺度？ 咁呢下就難咯。Now you take a look on question 2. A student compared the rates of reaction between magnesium and hydrochloric acid and propanol acid of the same concentration. The magnesium was in excess in both trials. The student measured the volume of hydrogen released at regular time intervals. The graph show the results below. Okay, again, testing of fair test, the concept of fair test. Can you write down the 2 factors that could be tapped the same in the 2 trials for the fair comparison?
Volume of acid.
Volume of acid. Volume of acid. Agree? The others, how about the others? Agree? Volume of acid. Now I try to mark it one by one, okay? Volume of acid. What else? Just free fall. 其他人呢 ？Free fall。話俾我聽。係梁柏強，一個。
Concentration of acids.
Concentration of acid. OK。係，仲有冇？要做 fair test 啊嘛，有邊啲要 keep the same？ 咁啊，梁柏強嗰個一定啱嘅，你知唔知點解？條題目講咗嘅。好，仲有冇？仲冇？曾海軒，啱啱講。聽唔到，梁明俊我係咪？講得講。
temperature of acids。
OK， temperature of acid 係，仲有冇？你全部淨係講 acid 講晒未啊
？Same amount of magnesium used.
Same amount 嗱又嚟啦，我哋 form one amount 我俾分啦，但係而家我唔俾分噶嘛。amount 你 refer to 乜嘢咧
？Same mole 啊 ，same mole，same
mole。Same mole of X of Mg magnesium. You mean? So how would you measure? How would you measure the same mole of magnesium? How?
Weight. Use a balance.
Weight. You are going to weight.
Weight.
Mass,
okay.
Weight. That these 2 concepts is different. Weight and weight. Okay, it's different, huh? Some slightly different. Weight and weight. Okay, weight verb. Weight. It is noun. Okay, weight of but indeed in science, weight and mass is different. Mass is different from weight. You know it in physics. Mass is not equal to weight. So you talk about mass of Mg. What else? How about magnesium itself? Can I do the experiment, one from powder, one from river? Can you think of one more factor?
Surface area of magnesium.
Yep, surface area of magnesium. You talk about the particle size of magnesium, okay? So magnesium can be powder, there can be a lump, there can be a ribbon, okay? So you are going to tell. Now, I would like to further split that too. Now, some of them, they are said to be correct, because you are going to talk about it as rate. Now, if you want to talk about the rate of a reaction, what are you focusing on? Is on this graph, which part? We will mention the factors affecting the rate. On the left-hand side or the right-hand side? Take a look. Now, I try to divide it into 2 parts as said yesterday. You still remember, I just divided into 2. The one with a curve, the other one with a straight line. Which one would say that the rates will be affected? 左手邊右手邊啊？如果講 rates 嘅話，佢會影響緊左手邊右手邊啊？
左手邊。
左手邊啊，右手邊咩嚟㗎？右手邊。
reaction completed.
Yes, the reaction has been completed. So you just tell me that the data to be got is different. For the one on the left-hand side, all those will mention how does those factors are affecting the rate. The other one, it is just tell you the number of moles of the reactant. How does it affect the number of moles of product? Can you get my point? So it is just merely mole calculations on the right-hand side, while for left-hand side, you are going to tell me the factors affecting the rate. So if I go back to this case, take a look on that. Which one, which is related to which? Can you make a matching? Take a look on that. We have mentioned those 5 factors, which will set to be factors affecting rate, and which one they will be related to the number of moles of reactant, and which will affect the number of moles of the product. 見唔見到？識唔識分？嗱，再望多次啦，呢5個係唔係都係講緊我哋所講嘅 control variable in this test 咧？最主要講 rate of reaction 嘛 ，rate of reaction 係睇邊啊？就係睇曲線嘅喎。咁所以我俾你再望多次，俾你再答多次。呢度呢5個入邊，得某部分係答案嘅啫，係邊啲？唔明。Hello， 陳俊。
concentration of acid。
係，跟住咧，仲有邊個
？temperature 同埋 surface area。
係啦，明唔明？就係左手邊嗰啲啦。所以頭先咧，阿 Sir 聽緊你哋講嗰時咧，我已經將你哋嘅答案分咗類㗎啦。嚇，左手邊嗰啲咧，其實就講緊呢個嚟㗎。咁右手邊嗰啲咧，佢影響緊啲咩啊？右手邊例如 volume of exit mass of mg 咧，其實影響緊呢個最終呢一個水平去到邊嘅，跟唔跟到？所以如果你問我 to make the two trials for fair comparison， 你要睇翻我想 compare 咩先 ？Go back to the purpose of experiment. The purpose of experiment is take a look on the question. What is the purpose of experiment? Compare the rate of reaction of Mg and hydrochloric acid and propylene acid of the same concentration. Can you see that? So this is our purpose of experiment. 目的，實驗目的。Do you understand? So if that is the purpose of the experiment, so the answer for A part should be the one in red, but not the black one. Do you understand? The two curves have different shapes because the strength of each acid is different. Write about the difference between the strong acid and the weak acid and explain why the two curves are different. Now, indeed, the concentration of acid has become the same. The temperature of acid is the same. The surface area of Mg is the same. But how come there is a difference in the rate? Especially at the very beginning. We call it initial rate. Tell me, what is the difference between hydrochloric acid and propanoic acid? You know what is this one, HCl? How about this? Propanoic acid, how is it called? We call it CH3, CH2, COOH, 甲乙丙丙酸. A good hint based on the formula of it. Can you make some guess? Yes, different strength of acid. Yes, please elaborate on these two. What is that as different strength of acid? You're going to compare HCl and CH3, 2COH, propane acid, in terms of the strength of acid. 溫翻書呢兩個係有咩分別啊？講強度 ，HCl is a strong acid with acid. Propane acid is a strong acid with acid.
HCl is a strong acid.
Yep, strong acid. While this one, a weak acid. So definition, please. Definition. What does it mean by strong acid with acid?
A strong acid completely ionizes in water to give hydrogen ions.
Okay, completely ionizes in water to give hydrogen ions. How about propane acid? It's a weak acid.
Partially ionized.
Yeah, partially, slightly, but slightly ionizes to give a hydrogen ion when dissolved in water. So, you go back to the explanation. What factors would really affect the rate of reaction? Now, concentration acid is the same, but what concentration is different? So as to make the rate faster. 有乜嘢係
hydrogen ions.
Hydrogen ions, yes, that's right. So the hydrogen ions, the concentration of hydrogen ions in these two cases, this one is higher, this one is lower. Do you understand? So how does it affect? Is the rate of reaction. You may say that this one should be higher and this one is lower. Do you find it very similar to what you know in acid and alkali? Now, of course, if you really want to be a bit more scientific, you do for the whole progress of a reaction. Okay, the rate would change. So what we mentioned about the rate of reaction is mainly measured as the initial rate. Okay, by determining the difference in the slope of the tangent at time is equal to 0. So what you just mentioned about rate of reaction usually refers to initial rate. Okay, do you understand? So be careful. You have to relate to the fact that the concentration of acid has been changed. Okay, now go back to our understanding of today's these two exercise is to want to talk about how does the rate of the reaction changes with that. So in this case, you may find that the strength of acid will affect the hydrogen ion concentration, which will affect the initial rate of ions. Of course, all these factors would also affect the rate of reaction, right? But if you want to make a fair comparison, you have to make sure that these three, the presence of these three will not affect the rate of reaction. How? You are going to keep it as a constant. So we will call this a controlled variable. Now, fine, this is a fact. It is a recall of the memories controlled variable. Do you understand? That's why I need to keep the same. Keep all those the same. Okay. Except strength of acid. So because I changed the type of acid, you know that the two acids, they are of different strength. So by comparison, you will have such cases. Now, of course, one more thing I would like to mention with you is on here. Now, you may get confused with these two concepts, right? Volume of acid and mass of magnesium. That is very natural. Okay, it does make sense that at the very beginning, you get confused. The reason behind is very simple. In Form 1, you do not need to get to know the concept of rate and mole. So for the markers, including me as a science teacher, at that time, I still give you marks. However, while in Form 4, if you write down these 2 points to tell it is a control variable in Form 4 chemistry, sorry, you cannot give you marks because these 2 factors doesn't affect the rate of reaction, but it does affect the number of moles of the product to be formed. In this case, it is hydrogen. Do you understand? So I change these 2, they will change the final line. It is up and down. Okay, you get my point. But if you change the one in red, okay, those 3 factors, they will make the graph just like steeper, less steep, or even less steep. Do you understand? So be careful, people, be careful about that. It seems that today we have fair enough to talk about not only rate, the factors affecting the rate, but also something about mathematics. So how will you relate them? Chemistry 呢一科係咁故弄玄虛嘅，故弄玄虛個位係咩咧？好多時咧，淨係得一啲數據嘅啫，而啲數據去到你嘅結論咧，嗰個中間嘅過程，你係需要你咧係要畫公仔畫出腸咁話翻俾我哋 markers 知咧，你係知道嗰個關係嘅，明唔明啊？咁呢個就係畫公仔畫出腸啦，係嘛？平時咧可能有好多同學你做呢啲題目嗰時咧，我即刻跳到個結論啦 ，concentration double，the rate 咪 double 咯咁樣。但係我一定會繼續問嘅，就係究竟明明我唔係俾你 rate 㗎，我俾你 time， 你點知等於同 rate 有關係啊？我明明係俾你 volume 嘅，咁你點樣可以話佢 concentration 改變嘅？咁你就要話翻俾我聽啦，跟唔跟到？明啦嘛？嗱，你要學識好長氣、好沉氣咁講清楚俾我聽，就唔係嗰個咩跳躍式嘅思維嘅呢度。嗱，你跳躍嘅話咧係會出事嘅呢度。好，話翻俾我聽，你今日有咩唔明？同埋0到10啦。嗱，我呢度特登就係講個例子嘅啫。我希望呢個例子幫到大家，呢兩個例子應該幫到你哋嘅。嗱，一定明咗呢個概念先，跟住我再轉其他 factors 啊，即係你好明顯你知道我話乜㗎啦，係咪？講完 concentration 咪逐個改咯，係咪啊？就 keep concentration the same 就睇 temperature， 跟住再睇 surface area 係咪啊？逐個睇咯。我哋係咁溫㗎嘛，係嘛？明唔明？咁同埋咧，今日咧就有個注腳未講嘅，就係喂 concentration 係會改變個 rate of reaction，咁但係點解會影響咧？我冇講到嘅。點解？我就知現象啫嘛，我知其然啫嘛，但我唔知點解嘅，係嘛？你有冇留意到？我冇講過點解，我就係話俾你聽係有改變，冇講點解改變。So we will have a coverage of it in the next lesson. Why? So the why, the reason behind this is backed up by the theory. We call that collision theory. Collision theory. So if you are interested in it, okay, for the time being, you may type the word collision theory in the web, okay, and try to understand it by yourself first before we come, okay? 仲冇其他嘢問？冇啊嘛，係咪？ Okay, I'll see you guys next Tuesday, is it? Next Tuesday in the next lesson. Okay, see you guys. Bye bye.
Bye bye. Bye bye.
Bye bye.
Bye bye.
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 Bye guys.
Bye bye.
Bye bye. Bye bye.